Geography is essentially physics but slower. It's falling water moves stuff. So here in Switzerland, in Saas, which is just down there, and we're doing some geography with the NST. Geography, of course, is just physics but slow. And this is Claire Udale, who's going to tell us what we're doing with this study here.
So we're underneath the Trift Glacier, that one runs up there, and we're on what's called the outwash plain. And we're going to look at how the amount of water coming out of the river changes from now, which is the morning, to a couple of hours' time when it's had a little bit more time to melt. So our hypothesis is that the amount of discharge, the amount of water coming out of the river is going to get higher on our second lot of data to our first.
You'll know that the specific latent heat of water is quite high, so this is why glaciers are able to stay frozen for such a long time. And we're seeing how that water is melting throughout the day. Obviously, we're talking about Newton's law of gravitation. Everything is going to come down. The simple way of saying Newton's law of gravitation is what goes up must come down. So eventually, all that ice up there with the glacier will come down this valley, and it's very, very interesting what material it's going to bring with it. There is a real environmental thing to be discussing here as well, because Claire, when she came here only 10 years ago, the snout of that glacier was a good 50 meters lower. So these glaciers here in Switzerland in the Alps are receding. It's not a lie, they are receding. Whether that's natural or man-made or a mixture of both, we need to be finding out. And if you're interested in sciences, well, one of the things I like to say to young scientists is, well, you could save the world. Your discoveries, your work could change that course and reverse some of those changes that we are doing to the planet. Impressive how this huge mass of water has just ripped this hole in the earth. It's such a lot of force, bringing these huge boulders down here. We're walking just now on the lateral moraine. The boulders down there in the valley, they would be the terminal moraine. It's all a story of moving water, isn't it, sir?
So this has had a journey. This rock, if it could tell us something, it would tell us that it started life up there.
That's what you get for your...
Here, and in fact, it's broken here. But this is just smooth, I can tell you, this is absolutely smooth. How smooth is it up there, man?
So what they're doing now is taking their flow rates and their samples after a few hours. So this is now noon. And they're comparing the flow rate of the river now at noon, where we're going to have a higher intensity of the sun. So we're expecting there to be more melt. So we're expecting the river to be running faster. This is like the exact hat I was wearing in the 90s. This hypothesis was proved correct because, well, you can see how much faster it's running. You can't actually get across the river where you could earlier on. And some of the stepping stones we're using are covered. But their data, by using poo sticks basically to get a kind of flow rate, has shown that it's flowing much faster. And that it is deeper as well than it was earlier on.
So we're inside the glacier at the moment. We've come down some steps into a tunnel and they've carved out some ice caves from inside the glacier itself. There's various simulators, the avalanche simulator, which is terrifying, and then some viewpoints that we can look at down onto the valley, and it tells you at which points when the ice was laid down all the way back down into history. It might go back in time.
Should we press this button?